We're going to skip the intro now. Philipp again. I'll try some old school techniques for some modern stuff we are doing. What I will talk about today or now is, I think I called the talk Beyond MySQL, and what I will do is tell you a little bit like the story of our business intelligence infrastructure, which is actually pretty similar to what you did and what, where's our honeypot? What they did as well. But we didn't build it ourselves. So we have our own system, so we don't have an external one. We have a couple of parties we work with, but we basically built it ourselves. And I want to tell you a little bit how it evolved over time and what we are using now. And basically, I told you already about the third and pretty important component of it, Kafka, which is still part of it. But actually, we started out without. And what we always, one decision we made right from the start was to separate the analytics data from the live data. All that live data is separate. Game clients can do whatever they want. They shoot reporting somewhere else. So we had like always game 1, game 2, game 3. And actually in the beginning, we started out with just the MySQL database. And here like a web server which took the stuff in. Very simple solution, web server taking the stuff, basically taking Apache logs, separating them into tracking parameters, inserting into MySQL. No, my drawing. But that obviously has some problems because you have to batch process every 24 hours. So we pretty quickly ran into the problem that we had our reports in the afternoon because it took so long to process all the data, inserting it into MySQL. The bottleneck wasn't so much MySQL, but it was more like the batch processing you had to do because doing that in real time is possible, but not without inserting some kind of cool tool, which we did pretty quickly, and that was Kafka, which is like in here now. And then we still had our MySQL database. Now, before I go on about the infrastructure, some numbers about it. I already mentioned in the morning we have around 150 to 200 gigabytes per day, but the data is very different. You have to look, if you want to talk about the data, you have to look a little bit about the use cases, what you want to do with it. Now, we heard a couple of things already. Like, and what do we have in terms of use cases back here? We have one, which I showed in the morning already, with our daily report. Daily report, which we really love to have. When I was in the morning to check, was our game okay yesterday? Is like retention and all that stuff okay? Then we have like a website. What's the picture for a website? It's like reporting.wooga.com, which is basically an aggregation where we aggregate. You could call it data warehouse, even though we like to keep things trivial and I don't like data warehouses so much because they tend to be very complex. But actually it is something like that where we aggregate data. For example, what do we aggregate? We aggregate retention. So I look for all users who logged in yesterday. I update, we have a user state. Now every user is basically one of these MySQL tables, and the user we keep forever. So I check for everyone who logged in yesterday, when did they register, and I update their retention numbers. So I get like retention numbers pretty cheaply by just looking at the data yesterday. Same is something we do with monetization. So these basic metrics like monetization over 30 days and 120 days, or retention, or the only one-day metrics like daily active users, like all the numbers you mentioned, like most of them you can generate basically by this process. Now still getting Kafka, inserting it to MySQL, and then on the batch process every morning, updating these basic metrics. But, and another use case which is very frequently is our game analysts who sit in the different game teams who do their SQL queries for special stuff. You can get A/B tests or longer like analytics. You want to understand something. It's really like custom made, where you can't really define it and do it again because it's just custom and it doesn't make sense to really define it. So I have like the people sitting down here now on their SQL interface. And there it really becomes tricky because pretty quickly you run into MySQL problems. MySQL doesn't scale very well. Now, I kind of have a love and hate relationship to MySQL because I think when you're like a young startup and when you want to get something fast, MySQL is a pretty good tool because everyone knows how to use it, everyone can set it up, it's pretty simple, the interfaces are super simple, everyone knows SQL, nice and easy to get going, but it just doesn't scale. I mean, MySQL just does not scale. Now, you can cluster it, you can try to go big on it, you actually have pretty big hardware. We still have MySQL in our current infrastructure. We have a couple of different systems, I'll tell you in a second, and we still have MySQL for exactly this. This one we never replaced. This daily batch processing. And we do it on MySQL instances that have like the most expensive hard disks I think you can buy, these Fusion IO cards of 1 terabyte SSD cards for $20,000 each. And that helps you, but only very limited too. What we did as well on MySQL, which really helps a lot, and you just talked about earlier here. You just talked about a similar thing. You have these batch processes running on the data of yesterday. That's what we do as well. We don't do it in Hadoop, we do it in MySQL. And how we do it is that we basically throw out the old data. Now the problem with MySQL is that it doesn't like deletes too much, because then the data gets messed up and you need it all over the place. So what we do is that, thanks to Camille, we have a very nice process that we partition our data on a daily basis. So every day is in a separate partition, and we throw out the old partition, we drop the partition. So we never have to optimize the tables. They always like stay okay because you never delete anything. You just drop the old position and roll over the data like this. And like this, we can very easily define as well for each type of data how long we want to keep it. Installs, for example, we keep forever because it's not so much, and it's basically our user table. Logins, we have to throw away after like 30 days or something. Some other stuff like invites sent or invites received, we only keep 5 days because it's so much data. You have all these Facebook invites and we just throw them away after 5 days or even 3. And that helps us keeping our MySQL databases manageable and small. But of course, the guys down here, the game analysts, are not too happy about it because they don't have enough data to work with, and as well, even on the data we have, you can't really do joins. Now you can do this predefined queries, but joins are not really scalable. So, what do you when I started now about the time? Well, I just keep talking about it. So we thought, hey, we have to do something in here, because this is like MySQL right now. And lazy as we are, we would love to just replace this part and make them happy, and not changing the interfaces. Because if you change like interfaces, especially for people, people tend to not like it. You know that if you change process in the company, people hate it always. And that's why we try to really give them, or we look for a solution where they can, where every game analyst can keep their SQL interface with hard enough to tell them how to show them how to work with MySQL, and where they can keep their SQL interfaces, and our Kafka can still feed stuff. But we wanted to just have this part here scalable. And I looked around, or we looked around, actually Marcus looked around, at a couple of different tools, and we basically found out that the way you have to go is in these so-called column-based databases. Easier to recognize by their names. The big ones are basically Vertica and HANA. Vertica was a startup recently acquired by HP, or HP, I think, HP. And HANA is the SAP solution. And there are 2 startups or young companies in Germany who do similar thing. Exasol is one from Nuremberg, and Parstream from Cologne. And we looked as well at Hadoop with Hive, because Hive is kind of a SQL interface as well, so we thought, well, let's try for one open source solution as well. I looked up the internet before I did the talk, and there are actually a long list of other companies we never really looked at, but I have a feeling we had a pretty good benchmark of the companies we looked at. So we actually, we pretty quickly, interestingly, discarded from our evaluation Vertica and HANA. Not the first one to throw out, because they're like the most renowned ones, but about HANA, everyone told me it's not ready yet. That I know BigPoint is using it really heavily, but I heard as well BigPoint has some connection with Hasso Plattner, and he knows about the project, and he actually really threw 60 SAP engineers onto the project to make it work for them. And that's why they are like more or less happy. They're still working on that full time. But since we don't know Hasso Plattner, no, basically out. And about Vertica, I don't know, we have kind of a fable for startups, for smaller companies. So we said like, hey, let's try the smaller ones. I really have some problems with like these big company consultants and stuff, so we said let's try the smaller ones. Exasol and Parstream, they're all like smaller companies. So we put them into our Kafka, The exasol is how they're written, and the, what did I say, path stream. And we, of course, already had our S3 down here because we did it for backups by Amazon, so it was pretty easy to make a elastic Hadoop setup on top of it. And these are the three which we evaluated. And let me start from the bottom, maybe. The S3/elastic MapReduce combination. I think that's the one that you're using as well now. For our use case, for the guy up here, it didn't really work out. Usability, in my perspective, really was terrible. I mean, to get a job to run with that Hive thing, you really had to log into some console and start that, and then you had to. I mean, we had an intern, a really good intern, working on it for 2 months to try to make it work, and he didn't fail because he was an intern, but because it was just too complex. I mean, and the other pretty significant problem is that it's quite slow. Not really like what you usually hear, but I mean, especially compared to these guys, it was really pretty slow. I mean, the problem is, well, actually, I'll tell you like about the results in a second, not to spoil it. So, the second one we looked at, Pathstream. Pathstream, a very interesting company from Cologne. We got talking quite a lot because they were just in the middle of a financing round. They actually closed a very good financing round. They have Benchmark Capital, one of the, and Grant Fund, two of the most, how do you say, like random, like the most, the kind of tier A investors from the Silicon Valley. In it, managed to close like a $5 million round of funding. So actually really interesting, but they want to focus on the US, which was not really a problem. The main problem was basically two things about them. One is their user interface as well is not really that amazing yet. It's like console-based as well. So I mean, you know, because we have quite a lot of game analysts, it was really important for me to be able to work on them. And Pathstream, in terms of like user interface, was not really to deliver a SQL-based graphical user interface. Not graphical in terms of, you know, like, oh, above I can type in my query and below I get my results. No, on the left maybe I see my tables, something like this, what people are used to. And Pathstream was not able to deliver that. And secondly, Pathstream is built on kind of predefined queries. Pathstream is really working well if you work on, if you know your queries in advance, if you know what you want to, what data you want to crunch and to look into. And if, like these guys, you do different stuff all the time. Pathstream is not optimal because then they have to re-index all the time and they have to make like their index work according to what they have. So even though very nice company, I like them, they were out. And Exasol was actually really good. We were really pretty impressed by Exasol because one, they had like this GUI thing where we could still do queries. Their SQL is very close to the SQL of MySQL. There's like the difference is neglectable, I would say. I mean, not neglectable. They're always like, if you use it heavily, you find stuff that doesn't work. But I was pretty happy about it. There was the one thing, and pretty amazing as well was like the speed. I mean, I think we had a hard time to find any query that took longer than 2 minutes, and like all of these queries that before in MySQL did not work or did not run through at all. What's the downside? I mean, so that's a good thing. So we are like, actually we just signed the contract just recently, and we will have Exasol additionally. We will not throw away MySQL quite yet because these two here are still working and don't touch a running system. No, if you don't have to. Maybe in the future we will, but for now, Exasol is our plan. We will still, of course, keep here the S3 Hadoop installation because I think the problem with Exasol is, of course, it's commercial, so you have to pay money for it. And it's not incredibly cheap because it costs in terms of like the amount of data you put in. So the more data you put in, the more you have to pay for it. Pretty difficult to understand how much it costs because they charge you the RAM you're using and you don't really know how much RAM you're using. But we have a rate as well. They have, there are a couple of companies as well as kind of references. We looked at two. Sing is using them. I think Sing is their biggest customer, and here the Zalando guys around the corner are using them as well. I talked to them, they're more or less happy as well. Which means for a system like we have it, they are a good option. how do they work? I mean, how do they achieve that? I already told you, it's like, I mean, one thing is they work in memory, which already beats MySQL and Hadoop in terms of performance. So you don't have to copy the stuff back and forth. And they can cluster, so yeah, they can like scale it, yes?
I was thinking about the parsing. How was the speed compared to the
Similar, right? Similar. They're like kind of, I mean, they're both, for us, I mean, they advertise a lot with their speed because they're like, people use them for real time as well. Like in this search engine optimization area, a lot of people use them to calculate your stuff in real time, which is not something we use. So for me, it doesn't really matter if it takes 1 or 2 minutes. So it's not, or like 10 seconds. That's for us not a metric, or not an area where it really matters. And they were basically totally on the same level. Yeah, they do it by in-memory and by these column-based databases. Now I looked it up on Wikipedia, but it was too complex, so I can't really tell you how it works. I mean, basically, they order the data a little bit differently, but yeah, I think I'm the right guy to explain to you why it really works, but it does work. What else do I want to talk about?
You were to tell us about the clustering of memory, in-memory stuff. So if you could additionally
well, but yeah, I didn't have too much to add. I mean, they clustered and they scale more or less horizontally. Yeah. One thing about the, I mean, the curve I kind of found out of it is like if you look at time to data, the relationship. Now, like the amount of data I want to crunch and the time I need for it. MySQL obviously has kind of this curve. Basically, after a certain point of time, then MySQL just doesn't work anymore. Now, it's just not possible to query a certain amount of data, but down here it's pretty fast. Now, Hadoop has, from my experience, the Hadoop curve is pretty straight, but starts very high up here. So the MapReduce curve is somewhere like here. So this is like MySQL, and this is like. You don't agree?
No, I think you're missing what I mentioned. I mean, if you have 2 Hadoop instances, it doesn't look like that.
Well,
then it would double the speed. With 2 Hadoop instances, it would double the speed.
How would you make it different? I think it still looks the same. I mean,
but you have these initial costs.
Because it scales linear with the number of instances in the cluster that you have. Almost linear, but yeah.
Yeah, that's why I have it like, more or less like, I mean, I have it like fascinating.
This is your data size. I mean,
yeah, the more data I have and the time really stays more or less the same. Now I can adjust with instances, so I have more and more data, and still the time is not really growing because that's what I want to say now. Even if I have like 5 petabytes, my time can still more or less stay on the same level because I can just add clusters to it.
But you could still have it faster if you just double the machines from the beginning.
If you have like the relation to MySQL, you don't get closer. That's kind of what my point is. That's why it's still up here. So you can throw 10 on it, but you still have to copy your data around and so on. While MySQL down here is like in 2 seconds, no? And it takes a while. Actually, this point is farther out than you would expect, no? Because MySQL goes pretty far. For this, like for the one-day thing that we're doing, I have a feeling MySQL is pretty close to Hadoop. Still, if you just process your data from yesterday, even if it's 100 gigabytes or something. So Hadoop really kicks in on a very high data level. And the extra sort and parsing guys, they are now in a curve like somewhere like, I don't know. I mean, here and then I don't know when they go up. I think at a certain point they will go up. Then they have the money dimension as well. But this is like kind of more. I mean, we should have the money curve for XSL, but it's kind of how my experience of data looks like. Yes.
Just out of curiosity, because I know that a few people have good things to say about MySQL cluster, but speaking of in-memory, have you tried it?
I read about it, but no, I've never tried it. It was kind of interesting, but I heard people say,
that's what you
Maybe I can help on this because I worked on an in-memory databases about 2 years ago. And we did tests with MySQL complete data set in memory compared to ×10, which is the main memory database of IBM, our own system of course. And MySQL was about factor 10 slower than ×10, which was optimized for main memory. Okay. So I think XSL is going to be faster than ×10. So.
So how does it work
Exasol, right?
Yeah.
We bought now a cluster of 6 machines, 6 or 7. I think 6 and 1 standby, so it's like a cluster of 6 we use.
And so how much RAM do they have?
A lot. They were pretty expensive. I don't know. Well, I don't know, maybe 250, 65 or maybe even more, maybe even 512. Something. I don't know. I mean, we calculated for about, yeah, I think only 256, 265, 56. Yeah. We calculate them right now with about like 3 or 4 terabytes of data is currently what we're estimating we want to put into it. And then, but they don't keep it all in memory. They like, I mean, since it's commercial, you don't really know how it works, no? And it's basically black box for you. But what I hear is like they mostly have the index in memory. Like put a lot of time and effort into the indexing stuff. It's like a former university group who spent a couple of years implementing this database solution.
But from the hardware side, you know how much memory the machines have?
Well, I could look it up, but I don't know.
Okay.
I can look it up now.
Well, I think one thing about
How much memory the machines have.
My question is basically I just want to estimate how much data you can put there theoretically. So what do you work?
But I think you can really calculate memory and compare it to data because they really do a lot in terms of indexing. So the relationship, yeah.
Well, I think the trick about complex databases is that we have really good means to compress data, because if you go on the column, there are many similar entries. So actually you only need a fraction of main memory compared to raw data. So I think you can really store terabytes of data on regular machines.
Yeah, the relation we see or we expect is like between 5 and 10% of like memory in use in terms of your data size. That's how they tell you like how the costs come up to. So
and that might be a full data set, not only the index.
And it's way better performance-wise, because what you are looking at is aggregating over all users, and that's common-based aggregation. So you have the comments in memory.
So okay, so to briefly wrap it up now, our system kind of right now, and we're still evolving and developing, so we're still like adding new stuff and changing our system, but right now we have like these 3 main elements, apart from a couple of smaller I mentioned earlier now. We have the MySQL for the daily crunching of yesterday's data. We have Exasol for our game engineers, where we have like a bigger amount of data. And we have S3 where there's like everything, if we want to make the analysis over the last 2 years. We don't really know yet when we throw out data from Exasol. We will have a look into that, but I have my doubts that we will keep like every single event that we ever had into the database, just not really point to it. And we will keep every single event into an S3.
What is the reason you didn't go for things like Teradata? Is it the cost maybe?
What's Teradata?
Oh, well, you have to look at it. That's the database from the 70s, which is totally parallelized, shared nothing, so you can just keep adding boxes, but it still runs SQL on it. And this is what things like eBay or Vodafone put their millions of users and petabytes of data.
I mean, we didn't look at everything. We looked at the 5 I mentioned and looked a little bit around kind of the internet before, but it's not that, I mean, we're still like kind of a young company, so it's not our goal to really make sure that we looked at every single possibility out there.
Well, this is a household name, so to say, with big data, Teradata. And so
Teradata?
So the point is only, I was interested if it was the price why you didn't go for that, because it would solve all of your problems.
I would give my doubts that there's still more. No, I mean, we looked at HANA and Vertica, so can't be about the price. I mean, I don't think you can get a lot more expensive than HANA and Vertica. I mean,
well then,
yeah.
Has anybody here, maybe for the audience as well, experience with using Elasticsearch for storing log data? Because many people told me that though it was not meant to be used like this, because it's received before. Has anybody experienced with using that?
Question is like using Lucene or Elasticsearch for
Only for logging. we have our log aggregation. We put all our log files into Elasticsearch and do basically have monitoring on that, counting errors. So that does work.
I heard about it once too, but never really went down that road.
Yeah, of course you don't have a SQL interface to that.
I mean, it's always depending on the use case.
Yeah, you can do joins and stuff, so it's really, I mean,
it depends on what queries you have. But I think it's pretty fast and it's free and it's easy to set up. So
Right. Anything else?